Okay, this is Chem Review Part 2. So I asked you to do the ionic bonding of beryllium and fluorine, and we drew the beryllium and we drew the fluorine, but fluorine's missing one in the outer shell, and beryllium has 2 in the outer shell, so it really could add 6, but that's a lot of work, so it's not going to add 6, it's going to give away the 2, and then it's going to be left with just this inside orbital. This orbital effectively disappears, and you just have the 2 in the outside. Because what's the golden rule of chemistry for Mr. Espenhain?
Wait, I wrote it down.
I thought you guys would all know this by now. Glenn! No, it's not. Wait. So every atom wants what? A full outer shell. Say it with me. Every atom wants. No. Every atom wants. A full outer shell. Okay, good. That's the golden rule of chemistry. That's not a real thing. I just made it up. But, you know, it's helpful. Okay, so beryllium wants to give away another. Who's it going to give the extra electron to?
Fluorine?
Yeah. When you mix 2 elements together, is it just like one atom of each element? Or is there like a whole bunch of atoms? I'm just going to tell you there's a whole bunch. It would be really hard to get 1 atom of fluorine to mix with 1 atom of beryllium. Usually it's like kabillions and kabillions. So it's just going to bump into another fluorine atom. And this, oh, you tell me what's going to happen next.
You're gonna have a full electron on fluorine and 1 electron with.
What's going to happen to this electron?
It goes to the outer shell.
Yeah, it's going to go here. Right. So it's going to go doot. And it's going to end up as part of that other fluorine atom. Okay. So what we're left with here, are we left with atoms?
No.
No, they're not atoms anymore. We don't call them atoms. What are we left with?
Electrons?
Ions.
Good, ions. Everybody say ions.
Ions.
Tell the person beside you what an ion is. So we are left with ions after this reaction. And I'll just put in, who said something about charged atoms? Good. So an ion is just an atom with a charge, basically. Let's name them. So what would the beryllium atom have now? Beryllium would be +2 or -2? +2. Yeah, because it lost 2 electrons, right? Are electrons positive or negative?
Negative.
Negative. So if it loses 2 electrons, you're gonna have 2 more protons than electrons. So you got 4 protons and only 2 electrons, so you're +2. What about the fluorine? Close. Yeah. Why is it -1 and not +1?
You're adding more electrons than the protons.
You're adding electrons, and electrons are negative, and you're just adding 1. Now, it's usually written like this. You don't really write in the 1. You just put the negative, and that means -1. It's important to understand This is not a molecule. Mateen, you with me? What is this not? Can you hear me? Okay. Go ahead. What is it not? Or what is it? What do we call this now? You have this, it is ions, very good. So these are ions. We call this an ionic compound, but it's not a molecule. It's kind of interesting. Okay, so I'm going to write this down. And what we would call this is beryllium fluoride. An ionic compound. Not a molecule. So that's kind of a common misconception that you think that when we do, oh, it's fit today, I just realized. We have 20 minutes. I've been talking at you for too long already. Okay. We call this beryllium fluoride. It's an ionic compound. It's not a molecule. So it's ions. Now, will these two things stay together? Will the atoms that transferred electrons, will they stay like? Generally yes, but Mateen? You think yes? What's holding them together?
A knot.
No, not a knot. They're not tied together.
This is science.
If this one is positive and this one is negative, are they attracted? Yes, they are. We could actually calculate the amount of force that is attracting these two. There's a formula for it right up there. That's physics. We won't do that today. This is positive, this is negative, opposites attract. But it's kind of like it's an electrostatic attraction. They're not tied together. So if there's another fluorine here, another fluorine here, and another fluorine here, and they're all ionic, this guy is attracted to this fluorine, but he's also attracted to that fluorine, and that fluorine, and that fluorine. So it's kind of fluid. And that's why we don't call it a molecule, because those beryllium and the fluorines, they can kind of like, they're all over the place. It's like the 60s, you know, they're like attracted all over the place. Molecules are held together really tightly. Okay. And I'm going to show you that right now. Lewis structures. Those Bohr models are great. What's the problem with them? What do you hate about Bohr models?
They take long.
Thank you, Nathan. They take a long time to draw. There's too many circls and too much things, and we're lazy as scientists. So we don't want to deal with them. So with a Lewis structure, it's only the symbol and the valence electrons. What are valence electrons? Sorry, I'll let you write first. Shrish, tell me.
It's the outermost electrons in the outer shell.
Let's give him a call. It's a good day for Shrish. He got his hug and the call. Yeah, he's absolutely right. So valence electrons are the ones in the outer shell. Now, we have this handy dandy table. So if you're wondering, okay, Mr. E, I have carbon. How do I know how many valence electrons it has? Do you have to draw all the orbitals and everything to find out how many valence electrons are in carbon? No, what do you have to do?
Check the number of the weight.
Yeah, you could do that. There's an easier, quicker way.
Check weight is in the periodic table.
So you just, I should turn the video. Hi video people, hope you're having a great evening studying for your chemistry test. Carbon, when you find it, is in the second row, right? So you just count where it is. In other words, you count what column it's in. You start at the front of the row and you go 1, 2, 3, 4. Carbon is in the 4th column, so it has 4 valence electrons. It's as simple as that. Okay, look on your periodic table and tell the person beside you how many valence electrons are in sulfur. It's number 16. Sorry, it's over here. Put your hand up when you get it. Elika. How many valence electrons does sulfur have? Is she right? Who thinks 6? Yeah, give yourself a golf clap. Oh, come on, give yourselves a golf clap. It's Monday morning. We need clapping and coffee. Oh, sorry, I didn't offer you tea this morning.
How do we get the valence?
The valence. Here's sulfur, yeah? So you go back to the beginning of the row and you count 1, 2, 3, 4, 5, 6. That's it. It's the number. It's the column number that you're in. Okay, so draw a Lewis structure for the following. Draw it for beryllium, for fluorine, for carbon, for nitrogen, and for oxygen. Let's do the first one together. This is as simple as it gets. How many valence electrons does beryllium have? 2. And so what you do is you start up here and you go 1, 2. Done. So much faster. Okay, fluorine, what's your guess of how you would do it? How many valence electrons does fluorine have? 7 valence for fluorine. So the way you fill them in is you go 1 here, 1 there, 1 at the bottom, 1 on the other side, and then you go and then you make your pairs. So what we're doing is we're doing pair on top, pair on side, pair on bottom, pair on other side. So you fill in this pair, and you fill in that pair, and you fill in the other pair, and then do we fill in the last one?
No.
No, because it's finished. There's a reason that you fill them in that way. So you guys try for carbon, nitrogen, and oxygen, and I will fill them in as I go too. Put your hand up if you got them finished. Excellent. It's fast, right? Okay, so just looking at beryllium and looking at fluorine, it's really easy to see what's going to happen, right? If you just took this fluorine and you just went, this would, oh, my video's on the wrong place now. Sorry. If you took this fluorine and you just smudged it in there, these two electrons would just fit together, right? And it's an ionic bond. We don't really draw them that way because when this becomes an ion, these two are gone, right? And so when this goes over here, what happens to the fluorine's shell? When this electron goes to here, what happens to the fluorine's outer shell? Go ahead. Mateen. It gets full. It's full. And then it's happy and stable. How many electrons does carbon need to be full? It needs 4, right? How about nitrogen? It needs 3 to be full. And how about oxygen? 2. Now, carbon, nitrogen, and oxygen are really involved in organic compounds, the things that make you. And carbon is the base of most life because it has all these crazy shapes it can make because it has 4 bonding sites. So let's do a Lewis structure of carbon dioxide maybe. So if you said CO2, what you would do is you put the C in the middle. And it has its 4, but actually, should we do that? You have to draw it a little bit differently. You have to put the 2, you have to put them in pairs. This is where it gets complicated. I probably shouldn't have done this one first, but that's okay. So there's 2 oxygens, and the oxygen comes up to the carbon and says, hey, I need electrons. I need 2 electrons. And it says, well, the oxygen says, well, I should have done that in a different color. Sorry. I'll do this one in a different color so you can kind of see what's what. So oxygen has 6 valence electrons, right? And it comes up to the carbon and it goes, dude, I need 2 electrons. And carbon's like, yeah, cry me a river, I need 4. But they say, well, how about this? How about we take 2 of my electrons and 2 of your electrons and we share them? So what happens is these 4 electrons, they kind of spend like half their time around the oxygen and half their time around the carbon. And they kind of share them like that. And then it grabs another carbon or another oxygen and it does the same on the other side. And so these 4 get shared with the carbon and this oxygen. And you end up with this, what's called a double bond. So if you share 1 pair of electrons, that's a single bond. If you share 2 pairs of electrons, that's a double bond. So we'll say sharing 2 pairs of electrons equals double bond. Oh, sorry. Now, this is a molecule. It's not an ionic compound. And it's using covalent bonding. So covalent because we're sharing valence electrons. So I'll say this is called Try to do CH4 and see what you come up with. Yeah. Luckily, I made a video so you know.
Oh, I mean the back of the page, I mean.
Okay, give me a minute here for everybody else to finish. I'll move it back. We have all 5 days this week, right? So I talked at you all day today. I'm very sorry about that. On Wednesday, what we'll do is I'll give you the work class. So on Wednesday you have class before lunch. So come ready to work on this. I won't give you any homework today. You can work on this and ask me questions. And also, you can have time to work on your presentation project, on your investor conference. And we'll talk more about that. Wait, I gotta show you this CH4. See if you got it right. And oh, Nathan, what do you have to remind me?
Yeah, you have to upload it to you. I remember.
Who got something like that? Yay! Good job.